Hey, it's a beautiful Saturday morning. My name is Eric, and I am making faces that you can talk to with web programming techniques. Let's demo. It's very important to demo. At the very beginning of each stream, I want to demo. And then after I demo for a bit, what I just did yesterday, I get to working. Because then it gives me more stuff to demo the next day. If I don't do the work, there's no demos. The demos are more fun to watch, but the work is required in order to have something to demo. All right, so you understand the relationship between the two things. So let's demo. All right, and I'll go to my localhost where this is all happening. 3,000, is that it? That doesn't seem right. Let me come down to my cancel. Okay. Sorry, I'm doing a really poor job of demoing, but it's going to get better. Okay. Main thing is web faces on at 3010. Okay, 3010, and then we'll show face builder. Okay. All right, so there's this audio playing.
Could you stay over here?
And there's animation that's happening here on the mouth. Okay, that's not new. I'm not demoing anything new with that. But that audio file.
Could you stay over here?
Okay, remember that audio file. So then we go to Lipsgen, which is another page served by the same web app. It's loading up a language model for speech recognition. I say find words. It's going to load in that audio file, and it's going to find the positions of things. Okay. All right, so here's the audio file that plays. Could you stay over here? The words are detected. Inside of each word, the individual phonemes that produce the sound of that word are, I'm not going to say detected, guessed. I made an educated guess at where they might be. And it's kind of a coarse guess, a sloppy guess. So like if you look at the word stay, all I did is I said we've got 3 phonemes in it. I'll evenly space them. There are refinements to make that will cause that to be better, a better guess. All right. Then the thing that I did yesterday is down in this bottom right hand corner. This is the automatically generated set of lips animations. It's encoded in this format I call lips, L-I-P-Z. I've been using for a while. If I come over here, I can compare. Okay, the original lips file, this is the hand-authored one. And here is the one that was generated. I'll paste it in again, make sure it's still the same. Okay, so there's that one. They're a little bit different. Okay, but this one is not bad. This is the new one that's automatically generated. This is the one that I hand-authored. Okay, so I'll save this new one, and then I'll come back over here and play this again.
Could you stay over here?
And that's the automatically generated mouth animation. And it's not doing bad. Like, it doesn't have anything obviously wrong with it. It could be tighter. It could, like, have a good, this person is talking feel to it. It's not there yet. It's a little bit like watching a very artfully done foreign dub, where they make an effort to pick words that match the speech animation, not speech animation, the lip movements of the actor in a different language. So if you go and you watch something like there's this new series from the people that did Dark. I think Dark probably falls in this category too, but I was watching this new thing. It's called like 16, no, it's called like 18 something. It's about a whole bunch of people on a cruise ship. Anyways, this German language TV series has dubs in it, but the dubs, it takes a while for you to figure out it's a dub. It takes like a minute or so, because the mouth movements that you see on the screen are pretty close to the dubs put on top of them. And that's because they were clever in the words they picked for the English language to match the German. So it's kind of hard to tell that it's dubbed until you look really close. So it's the same with this. It's off a little bit.
Could you stay over here?
But not much. And this is before I get to all my refinements. So if I come over here and I take this one that was auto-generated, then I compare it to the one that I hand authored. Here's the difference. The words are starting a little bit later and ending a little bit later. So I can see, so this is could. This is the original one that I did, okay. Then here is the could that came in. It's starting a little bit later, right? And not much though. So each one of these spaces here, that's 1/24 of a second. How long is 1/24 of a second? That's 1,000 divided by 24. That's 41 milliseconds. So that gives you some idea of like just 40 milliseconds. What is that? Okay, can you picture 40 milliseconds? It's a little bit hard. So imagine you count as fast as you can during 1 second. 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay, maybe I got in all 10 of those numbers in that 1 second. Maybe I might have been close. It was tough though. It was tough to hear them. So that would be each letter or each number that I spoke 100 milliseconds apart. 40 milliseconds apart would be if you were somehow able to say like 22 numbers inside of 1 second. I can't even articulate, what that might start to sound like. It's just impossible, right? Suppose I just make a duh noise. It's just so close, right? It's negligible. You could probably barely detect it with the human ear, the difference. Just barely, though. Like if I played two tones that were separated by 40 milliseconds, it would just sound like one tone to you. It'd be like just a tiny bit of distortion in the two tones. That's all it would sound like. So this little frame here is super small. But I can look at it and I can see the average delay or lag on each of these words positionings as reported back by this kind of black box piece of complicated speech recognition code that I don't want to get deep into. I can look at those starts and I can say on average they're all late by 40 milliseconds, say. Then I can just correct in advance. I can say let's just shift everything by 40 milliseconds, and then that would be bam, like that. Maybe it's a little more than that. Maybe it's more like 80 milliseconds. And then this K is closer, pretty close to the other K. This S is pretty close to the other S, negligibly distant from it. Over is right in the same frame. H negligibly different. Okay. The other things that are different. So when I'm hand animating, when there's a couple of consonants together, I just combine, or I don't combine. I pick the one that I think might be of higher value, and I use that. Another thing that I'll do is I'll err on the side of spacing, having like an extra frame in between these visemes, because if you use that negligible distance of 40 milliseconds to show 2 animation frames, your eye can't really make them out very well. It's just looks like a busy mouth, you know, a busy mouth that you don't quite trust as being realistic. You get into the uncanny valley because you don't actually see people talking that fast. What they do instead when they're talking is their mouth is a little bit lazy. Like if it's already making the sound of a d, it's already got its mouth in that position. Your mouth isn't going to move that much. So in hand animation, the top row, I consolidate these 2 consonants. This algorithm is also saying when two phonemes land right on top of each other, I already have this working, I will show the one that's more expressive, is in terms of like if you see that, it means something to you. So the FV, one of the very most expressive things to show in animation, I favor showing that. The L, that's your lips pretty wide open, and your tongue a little bit out to make that L. Lollipop. I won't gross you out with my tongue wagging, but yeah. So F, V, L, those are like the superstars. If you get a chance to show either that one or just a plain old ordinary consonant in lip animation, you show your superstar first. It's like if you had a bunch of comedians, a bunch of open micers coming in for a comedy night, and suddenly Dave Chappelle drops in, you bump whichever open micer happens to be on, and you put Dave Chappelle in because, wow, why is he even here, you know? So there are certain supervisemes, F, E, L, that you put out front, and then there's maybe some other ones that are like second stringers, like W and Q, that you want to show lip animations for first. Okay, how else is this different? As I was talking about earlier in the stream, the spacings of the phonemes that I picked by hand animation are actually aligned with what's going on in the audio. So if I come over to the audio here, we've got, you know, this is what like a hand chosen spacing looks like. If I look at stay, this whole thing is A. S and T finish up in the first half pretty quickly, and most of the word is A. So what I've got here with just using like a naive equidistant spacing on my phonemes is we say the S takes 1/3 of the word, the T takes 1/3 of the word, the A takes 1/3 of the word. But the more accurate way of doing it is S and T go together in the first half, and then A happens, which is what this is representing up here. Now I put I took out S and T I took out the T out of the original hand-authored animation because it's represented with the same viseme as S. There's no point in showing the same viseme twice inside of this code, so it's a simplification. So the positionings of these phonemes can be better. What I'm going to do today, in this session at least, is work on these rest symbols. These rest symbols are what makes the mouth close. So if I come back to this guy, here's my little puppet here, and I say, here's the different visemes that correspond to different utterances, right? Okay, there's one called rest, and that just means put your mouth to a resting position. You're not saying anything anymore, and that'll happen at the end of the audio file. But sometimes it should happen in the middle of the audio file. If I have in that speech audio file, could you stay, pause, over here. There should be detected silence between stay and over, and this rest viseme should be put in there. Okay. So today it's all about the rests in this session. I think in an hour or two, I'll have some intelligent handling of rests. And then I think I'm pretty excited about is that already, without making all the refinements that I intended to make, I have pretty decent automatic lip animation. It's not fucking bad, to be honest. Like, I could live with it now. But the exciting thing is, I know all these other things I can do that's going to make it better. By the time I'm done, it's going to look as good as like Toon Boom. It's going to look as good as, I don't know, just like commercial off-the-shelf animation software that's currently doing kind of a mediocre job at automated lip animation. And I think I'm going to crack it so that I barely have to think about lip animation in the future. Just collect a ton of voice-over audio. Bring that into a streamlined workflow. Get all this lip animation automatically out of it. Here and there I might go in and touch up, not that often, but mostly it'll just work. And with the other tools that are part of this system, it's just going to be possible to collect massive amounts of voice acting and put them into games and multimedia projects. And not just for me. Of course, I want it for my own projects, but all this is open source from the beginning. Not very usable now, but it's all out there in open source and will continue to be. These will be tools that you can load up in your own web browser. You can use them, produce your own lip animation with faces. You'll be able to build these faces from scratch using parts, and they'll be your puppet. They'll do what you want them to do, and there'll be easy ways to get them to talk. There'll be easy ways to talk to them, right? Because there's speech recognition built into this platform as well. So now let's move on to adding rests. Okay. Oh, it was a weird little switch between my demo and then the more contemplative working in code thing. Where am I going? I've got this lips generation util, and I did write some code last night to throw a rest on the end of the audio, and I realized that's not quite right. It's not quite right. What I need instead is I need something that adds in the rest phonemes based upon words ending, which is information I already have. So coming from the top level of this, here's the function that does all the automatic stuff. Here's the top level of it. It passes in an audio buffer, this debug capture, so I can just throw some things into this object that get passed back. It can be displayed. And it returns this stuff here, lips text, I call it. Let me undo this because I want that to represent the original, not the junk I'm putting in there for comparison. Okay, so it returns one of those lips things from an audio buffer. Okay, so this extractor generates a word timeline. It does that using speech recognition from 3 libraries: Vosk browser, calling into Vosk, calling into a bunch of Caldi code. Complicated stuff down there in the speech recognition, but very powerful and useful the results of it. It works like a champ. Okay, so I get the word timeline. That's a list of all the words that were recognized inside of the audio, where they start and stop. Okay. Then I say, give me all the phonemes that correspond to the words. That's where I'm going to want to refine the spacing of phonemes, but also I can add in some signals to say here's where the words end with rests. And I may need to pick like a code for the phoneme. Oh, I don't have to. I already have one. I'll use the rest phoneme code and insert that into the timeline. So this is the function I'll end up changing. Okay, so the phoneme timeline will come back. Now I can do another pass on the phoneme timeline if I want, using the audio buffer to detect my own silence. But I feel like they're probably pretty good, VOS browser, Vosk, etc., at finding the ends of words. I see them a little bit off. It looks kind of like everything's skewed a little bit by an offset. But I think the best thing is to use those words returned from Vosk to say where the rests are going to go. I might get a little tricky with it and say let's chop out some of the rests if we're very close to the start of the next word. There's a good reason to do that. Because when you're talking and you have two words close together, your mouth doesn't come all the way closed between those words. There's some kind of minimum delay between words to choose before you show this resting mouth movement. And you kind of know when you're speaking when you're doing it too. If I say, could you? Or I say, could you? Like, you know there's a rest there. Like, you know that your mouth probably closed between those two words, or at least it would be natural for it to. But if it still feels like at the end of the first word, like the motors are still going, then you kind of instinctively know that your mouth isn't closing. At least I do. I don't know. I think a lot about mouth, so maybe those thoughts go through my mind, but nobody else's. I guess that would be more likely. But certainly when I'm thinking about speech recognition and what my mouth is doing, stuff like that, it's pretty easy to predict for myself when it's happening. So I think if I just test it out a little bit and kind of find that edge of where my mouth will stay open, I'll just be able to come up with a constant, and I'll be able to say this rest would need to be suppressed if the distance between the end of the word and the beginning of the word is less than X milliseconds. I'm guessing that number is going to be something like 200 milliseconds. 1, 2, 3, 4, 5. That's 200 milliseconds, the distance between those two numbers. Okay. Okay, the rest of the stuff, after I get the phoneme timeline, I don't actually need the phoneme timeline. This is important, yeah. Phoneme timeline here, I was wrong when I said I have to fix this function. It's just used for debug info. And what I should honestly be doing is using this other function Nope, I'm wrong. I was right the first time. Okay, this is used, but this Viseme timeline is fake. It's used just for debug info, and it would be better if I generate it from this phoneme timeline. or from the lips text that came back from this function. Okay, cool. But that's not important. That's outside the scope of what I'm trying to fix right now. To do generate from lips events for better visualization. Okay, I gotta use the restroom. I'll be right back. I gotta get some more coffee too. I'll be right back.
Just look away. What a bruise. Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather we not focus on the
That's a
actions.
bad look. He's upset, but he's always upset.
She's probably fine. Don't draw attention to
I
yourself.
don't care if she's a pusher.
Why?
It'll go back to normal. Just wait a
Don't
bit.
want to ruin it for everyone else.
Send the other people and see what they say.
Okay, you're saying
Hey,
she's too
nobody
pushy.
died. You should be more
Can we
free.
get a beard in here? Why is it that hard? She just wanted people to clear a path.
She pushed someone
She's one of those.
in the first place. But do we understand?
Hey, just look away.
What a bruise.
Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather we not focus on the
That's a
actions.
bad look. He's upset, but he's always upset.
She's probably fine. Don't draw attention to
I
yourself.
don't care if she's a pusher.
Why?
It'll go back to normal. Just wait a bit.
Don't want to ruin it for everyone else.
Send the other people and see what they say.
Okay, you're saying
Hey,
she's too
nobody
pushy.
died. You should be more
Can we
free.
get a beard in here? Why is it that hard? She just wanted people to clear a path.
She pushed someone
She's one of those.
in the first place. But do we understand?
Hey, just look away.
What a bruise.
Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather we not focus on the
That's a
actions.
bad look. He's upset, but he's always upset.
She's probably fine. Don't draw attention to
I
yourself.
don't care if she's a pusher.
Why?
It'll go back to normal. Just wait a bit.
Don't want to ruin it for everyone else.
Send the other people and see what they say.
Okay, you're saying
Hey,
she's too
nobody
pushy.
died. You should be more
Can we
free.
get a beard in here? Why is it that hard? She just wanted people to clear a path.
She pushed someone
She's one of those.
in the first place. But do we understand?
Hey, just look away.
What a bruise.
Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather we not focus on the
That's a
actions.
bad look. He's upset, but he's always upset.
She's probably fine. Don't draw attention to
I
yourself.
don't care if she's a pusher.
Why?
It'll go back to normal. Just wait a bit.
Don't want to ruin it for everyone else.
Send the other people and see what they say.
Okay, you're saying
Hey,
she's too
nobody
pushy.
died. You should be more
Can we
free.
get a beard in here? Why is it that hard? She just wanted people to clear a path.
She pushed someone
She's one of those.
in the first place. But do we understand?
Hey, just look away.
What a bruise.
Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather we not focus on the
That's a
actions.
bad look. He's upset, but he's always upset.
She's probably fine. Don't draw attention to
I
yourself.
don't care if she's a pusher.
Why?
It'll go back to normal. Just wait a bit.
Don't want to ruin it for everyone else.
Send the other people and see what they say.
Okay, you're saying
Hey,
she's too
nobody
pushy.
died. You should be more
Can we
free.
get a beard in here? Why is it that hard?
All right, back to it. So then, word to phoneme timeline. Okay, so yeah, it's right here. Here's the place where I need to figure it out. Let's do, oh, I already got this phoneme now. That's good. Okay, so the rest. Let's say if word timing end time was, I'm using this so much I might as well destructure them. Const start time end time equals the phoneme, and then also I need no, don't need anything else there. Okay. Oops. Okay. So word timing. Word no up here. This is wrong. Don't need that. If this is the last word, or the next word start subtracted by this word's end is greater than a certain threshold duration, and we will put a rest at the end. Okay. Okay, so then this is going to be word timeline word no plus 1, the next one. Get their end time minus actually their start time minus end time is greater than rest between words threshold. Yeah, I'll go with that. If that's the case, then phoneme timeline push. Let's see, this will be rest. This will be end time. Okay. Now, do I have any codes for this? Okay, this is what time. Right. Okay, and this is word time. Okay. Okay. I'll start with my little constant that I guessed at. I was saying 200 milliseconds. This is kind of a silly convention I have. It's just that I know it takes a little bit of execution time, just a tiny little bit, just a ridiculously small amount to set this constant variable. So normally you'd put it inside of the function like this. But the old school coder in me says, that's wasteful. You're gonna initialize that variable every fucking time we call the function. So I put it outside here. Why do I tuck it right next to the function? Because it really is meant to be just for that function. If I felt it was going to go with multiple functions, I would put it in a section at the top of the file spaced out. It's a silly convention. Honestly, I should stick the constant there. It might be a way of me griping about JavaScript not having a static variable declaration capability. Because in C, you would say static const, and then it would do the rest for you. And it would only initialize that variable one time. All right, so that might have been really all the work that I was describing as my scope for the session. Let me do a few tests. I'm going to bring up this. Let's do new audio file. Okay, and just record. Hey, okay, it is recording. I want to do, let's see, 1, 2. Okay, that last one, it felt right on the edge to me of like the amount of time that should be needed. Hey, 1, 2. That felt like pretty close to like the minimum amount of time needed. So how much time was there between this and this? There's definitely kind of a trail off that could be interpreted as going all the way to the end without any gap. 1, 1, 1, 1, 1. 1. So let's say that's right on the edge. Maybe it's a little under what we want. 1, 2. 1, 2. 1, 2. I'm gonna look at my face big to see if my mouth is staying open for that. 1, 2. 1, 2. 1, 2. 1. 1 comes to a close. 1, 2. It's not really. It's not staying close. So the length of time must be further out. Let's try again. A little more gap. 1. Okay, that's what a mouth close looks like. 1. 1. 1, 2. 1, 2. Now I'm noticing I was wrong. My intuition was wrong. I thought that even just coming to silence meant that my mouth is going to close. It doesn't. It does not mean that at all. There's got to be something in my head that says I'm done talking now. 1, 1, 2. 1, 1, 2. 1, 1, 2. 1, 2. I'm going to put it higher. I'm going to put it at 500 milliseconds. Okay, back to this stuff. delete, record again. Okay. 1, 2. Okay. So what is this? This is going from 1.1 to 1.3. Well, that is 200 milliseconds. Let's go a little bit more. 250. Let's do 300. I'll split the difference between my two guesses. 300 milliseconds. Okay. Okay. So then there's another place where I'm adding on a final rest frame. Don't need it. Don't need it. Okay. So let's see how it does with the automatic. Okay, loading language model. Now click. Okay, there is like a thing at the end with 2 periods for some reason. I don't know what that's about. There's nothing between these words where it stops, and that's probably as it should be, to be honest. Okay, where's that extra period coming from? Oh, it's a double encoding. I don't need that there. Okay. Where's my ARPA bit? Okay, let's open up the other project that will have that. Okay, so there's no constant for rest. I just kind of need to know that that's what it is. Okay, no problem. Okay, so that should fix that. I think I might spend 15 more minutes refactoring a bit. There's some audio related functions I'm currently grabbing out of WebFace. Is it WebFace where I'm getting them, or WebSpeech? So yeah, it's WebFace. So I'm thinking, just for now, I'm going to use this as the home of all my audio common functionality. But at some point, I'm going to want to pull this directory out and put it in another library. I've just seen it can slow me down if I'm not like 90% finished with a library before I move it off to a library. That's the only issue there. But so far I've got some stuff to load a WAV file into an audio buffer. I've got stuff for playing the audio buffer and stopping it. I've got stuff for getting the audio context. See, here's my note. I'll refactor this into the audio library later. But I'll use this as like the staging area for what that audio library will be. I know in some other projects, I've got some code for doing sample calcs, and I would like to reuse that. Let's go look at conversations that had a lot of audio stuff in it. Yeah, so this RMS util is kind of important, although I might be getting like the same thing just out of those word positions that I would get from the RMS util, which would allow me to detect silence. This noise floor util I'm pretty proud of. That'll take a look at any audio file and say, here's where we think your noise floor is at. And it does it by just kind of finding the flat areas inside of that file. I think it also has got some stuff for continuously checking. Maybe not. All right. Okay, but the easy one is this sample util. Just grab that, bring it over to webface, add TypeScript file, sample util. Because I keep on writing this code again and again, and honestly, there's just a little moment where I'm like, am I multiplying by the sample rate or dividing by it? Because I can never quite remember that. So I have to stop and think about it every single time. And also in the code, if you have a function name that says what you're doing, then it's much more readable. I got some junk down here that's good for debugging, where I can say, oh, this audio file, just make it into some samples that are in JavaScript, and then I can use that for testing. I can write unit tests around those specific audio files. Okay, so for those to be available, they have to be exported. This is going to come from sample util. Play audio util. Let me look at that. This is a better interface than what I've been using. I've been calling the methods inside of here, but this is a better interface in front of that. So I'll go ahead and export that too. Okay. And I think the audio context to export. Wait a minute, what's in here? Lots of stuff actually. No defaults. Okay. It might be nice to not export the audio context. If I've got everything else in the audio library just being in front of that, then I can have my API be simpler. Okay. The place where I'm using the audio context is inside of speech audio though, and as I was saying a moment ago, I don't want it to... Oh, maybe I'm wrong. Maybe I'm wrong. I have play audio buffer in here. Okay, that's what I meant to do. So someplace I've got it directly getting the audio context and using those functions to play. But, yeah. Okay, so go back to web face. And I'm just going to look for sample rate. Inside of, where is it? Sample rate. Inside of source. You're doing case sensitive, that's why. Okay. So ellipse generator screen is where that's at. Let's come up here and do an import from SL web face for a bunch of stuff, but I gotta build it before it'll be available. So let's go over there. npm run build. Okay. Time to sample count. That's the one. Or is it the other one? Yeah, let's just put them both in. And then I'll go down and find any places that should change. Okay, let's see. Sample rate. Okay. Time to sample count. And do I use milliseconds or seconds? I'm using seconds. Okay. Why don't I just create a few more? Let's say samples to msex. Msex to sample count. Okay, and this will be msex. This will be times 1000, and then we will do a math floor on it. Should I do a math round? Round is better. Okay, do I want any math rounding here? No, you don't, because you want a decimal. Okay, but this overall needs to round. So okay, so that's the kind of 2 minutes of thinking I don't want to have to do again and again. Back to, let's see, build this. let's do M6. Yep. Come on, give me the hints so I don't have to go hop over to the other source. Okay, time then sample it. Cool. Okay, to sample it. Okay, down here, same deal. Okay, go back up top, clean up our imports. I should also check and see if I have any tests for these audio. Not here, but in the other files. Okay, so in conversations, no tests for those files, so I won't bother copying those over. Let's look at audio buffer util. I mean, this is a nice one too. Let's copy that over. I don't need it yet, but this is code that I know works, and I think it's general purpose. So, audio buffer util, right? Audio buffer util, yep. So yeah, this kind of stuff, this is hard won. It's the kind of code I don't want to write again and have to think about this problem here that I've already worked through. Yeah, good stuff. Good stuff. Okay, and this can just be that. Okay. So then come back to web face, and to get all the sample rate stuff or the sample conversion. Looks like, yeah, I think I got it. All right. What else was there that I was going to do? All right, let me just start thinking out the rules for optimizing the phoneme placement. Okay, come down here. Rules for refining phoneme placement. Okay, and I'll just kind of write them out as ideas. I might not do all of them. Favor one empty frame between phonemes. Consolidate phonemes that don't have Solid phonemes that don't have that don't change Visine, e.g. S and T have same consonant Visine. What else? Have consonant groups take a constant amount of time, and the vowels stretch to fill empty space. Find valley preceding a consonant. 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 Come on, former spelling bee champion. What do you think it is? Consonant. See if I'm right. Nope, it was consonant. Find vowel preceding a consonant and use as start of consonant. Is it the consonant to precede, or is it let's say preceding a word. Yeah, okay. What are the rules for this? What are the rules? So if I was here, and I think this is where it marks the start of the word, I want to back up to find a valley. That's a tough one though. I want to do other things before I do wave sample analysis. I kind of want to see how close I get without wave sample analysis, because that is a more tricky business. Put a little question mark there because I don't know if the algorithm is right. Okay, what else? If two phonemes, this is kind of a restatement of the first one, different way of saying it. Two phonemes are within X. Let's use one. That X might be the one empty frame. What else? I mean, that's a pretty good list. Yeah, that's pretty good. This one I might just cross out because I can see an argument that the Lips format is a little more powerful when it's not coupled to specific Viseme systems. There are some other ones out there that are a little bit more varied than the Preston Blair Visemes that I used. Like there's some that have like 2 or 3 more Visemes to them. They might distinguish between more phonemes than the Preston Blair does. In that case, I automatically hate you, by the way. Let's see what I can do to block. I'm just looking through the stream chat to see where are my widgets to just kill this bot, and it looks like they've kind of taken that away, or they put it someplace else than where it used to be. Oh well, I'll at least just kind of remove, clear the chat.
She's one of those in the first place.
But do we understand?
Hey, just look away.
What a bruise.
Pushing on its own doesn't matter.
Violet, I've pushed people by accident.
Rather, we no focus on that bad look.
He's upset, but he's always upset.
She's probably fine, but don't draw attention to
I
yourself.
don't care if she's a pusher.
Right.
We'll go back to normal.
Show moderation actions. I'm just looking at that. It's playing like the pause screen whenever I go to OBS.
You're saying she's too
Turn the moderation actions
Can
off.
we get
Yes.
weird in here? Why is it that
Okay.
hard? She
And
just wanted people to clear the path.
I just don't want to spend a lot of time on this. Just it's not that great
She's
to
one
be
of
doing that. Alright, so
Hey, just look away.
go to work. Then properties, and then x equals 2. Nah, that'll hide it. Okay, cool. Done with that. Alright, back to work, back to work. Okay, so I think I can leave that alone. This I could implement pretty quickly. Okay. So let's say that, you know, this is right next to this. I actually want to keep these both because they're a consonant and a vowel. That's cow right there. Whereas if it was S, T, and I think what's that one, AY? Then I just want one for the S and T. I might as well just say consonants, because I know from all those hours of and anime, it's the consonants that group up like this. I think the algorithm is like find all consonant groups in phoneme timeline. A consonant group is +1 consonant phonemes with one with less than 1 frame distance. Between. Okay. For each consonant group. For each consonant group. Find the most expressive in the group and oh boy, this could get a little bit tricky. Use. Okay, so this could be tricky because it could be like a consonant group could be like constraint. That's a good one. Constraint to I don't know if these are the right exact phonemes from Arpabet, but TR and then A and then N and T. Okay. So if they were all spaced like this, there's no consonant groups. But if they're like this, they probably will be like this. 4 altogether, constraint, all happening within a certain amount of time. Then I'd end up consolidating to the most interesting one, and these are all the same viseme. There isn't like one expressive viseme that beats them all. But if they're all within X amount of time, I just say, boom, okay, done. But suppose the speaker, instead of saying constraint like that, it says constraint. That's unnatural though. I don't want to have that edge case. Okay, another thing is I don't have real timings of these. I just have guess timings. So currently with my algorithm, these are all going to be spread evenly apart. So I need to detect these groups as a guess. I will assume then that a consonant group is within the same word. Even that has issues. Okay. A consonant group is +1 consonant phonemes within the same word or with less than 1 frame distance between words. So in my audio that I play, it's could you stay over here? Could and you are very close together. The D and the Y, they're right next to each other. Now I think Y might be like one of the high value consonants. Let me check that real quick. So come over to Arpabet. Arpabet, where are you at? There we go. What does Y go to? No, Y is just another consonant. So either D or Y. Well, neither is a higher value as far as expression. Okay. So could you, because could and you are just butt to butt, the consonant group I make should span words. Okay, so then after I do that, I can just delete the low value consonants, or I should say I can just replace all of those consonants in that group with the most expressive consonant out of all of them. Okay. So I think I'll write a function that just returns all the consonant groups. Let's see, what is that going to be? It's going to be function word timeline to consonant groups. Okay. And I'll pass in the word timeline. Okay, and it's going to return an array of consonant groups. Okay, and then that's pretty straightforward. I can write that. So what does a consonant group look like? It's going to be type consonant group equals range of time and the chosen consonant for that group. So that's start time, end time number, and phone. Representing phone, representative phoneme. Yeah. Okay, so that just kind of sums up the replacement. So then when I go down to figure out where all the phonemes are, I'll be able to say, okay, we found a phoneme. Is it between this start and end time? It is? Okay, if that's true. Oh wait, we don't have this start and end time concept. I could take the start and end time from the start and end times of the words, but I don't think that would be sufficient. It's too coarse. There's a word like Mississippi, and I'm doing consonant grouping for an S. Which S? It can't just be a range of the whole word. what are my other functions that I'm working with? Okay, so doing word to phoneme timeline. Here's, I have to kind of do something different here though. Like whatever this is doing now is just evenly spacing the phonemes. I need to bring the concept of consonant groups into that processing there. So I'm doing a little bit of kind of chicken and egg thinking here. Like if I had the times, then that would inform me of where the groups are. Since I don't have the times of the phonemes, I'm just going to make a guess of what they are a little bit later. I need to have some way to group them and pass it on so that decisions about the placement of the phonemes will be affected by the consonant groupings. Okay, so then it's like, what's the data structure that's useful to create for consonant groups that can be passed on to the function that performs the timings? I don't know the phonemes until I've broken them out, which is currently happening inside this function. Let's just say that this is all going to happen inside of the word to phoneme timeline. That makes sense to me. So if that's true, then let's kind of move this reference closer to that other function so I can think about it in terms of what's going on in that function. Word to phoneme timeline. Okay, this one right here. Okay, so it gets the phonemes here. I think there does need to be something like a first pass through all the words to get the phonemes. Let's get rid of this for now. I need to focus on this. Okay. Okay, I go into this function with the word timeline. I'm going to end up with consonant groups that span words. I could add those phonemes in there. I could add them okay, I think I got it. Okay. So this is code here, phonemes, phone dictionary find. Okay. So we'll say I don't think I need this anymore. Let's take that out. So this line there, inside. Okay. Okay. Consolidate. Consonants. And I could just do anyways, well, I'll consolidate them, and then I'll be like phoneme equals that. Code does not be exactly right. That's actually kind of incorrect right there, but just gain the algorithm right. Okay. So that will give me a consolidation. Inside of the word. It won't do like a span between next and previous words. But since I have been going through each word one at a time, I can check if the last word is close enough to do more consolidation. Okay. Previous word closer than one frame to this word. It's like for each word. I can pass in information here. Okay. Previous word. What do I have to pass? I'm going to have to pass previous word timing. Last consonant. I can do better. I can do better. Spanning consonant phoneme, which is going to be a phoneme timing or null. Okay. So inside of consolidate consonants, I'll already have, if this is present and not null, it means that this is ending consonant of the previous word, and the previous word was close enough to the current word that this will be the phoneme that should be used to make changes to, rather than if there's a consonant beginning of this phoneme, using that. Okay. Okay, this looks like the right algorithm to me. Say consolidate consonants, phonemes, and spanning consonant phoneme. Okay. What? Oh, because you don't know what's being returned. Okay, that makes sense. Function consolidate consonants, and it's going to be phonemes string and spanning consonant phoneme. We will return just a string. For the moment, I'm just going to return phonemes unaltered. And this could also be null. Okay. Okay, then down underneath I need to be able to figure out this thing here. Is there anything to reuse? No, I don't think so. Word no greater than 0. And word timeline. Word no -1. And time. This will be start time. Greater than span you know what? I think it's just, is it just this rest between words threshold? No, because it has to be consonants that are just close to each other. Okay. Greater than span consonant group, I'll say less than. Between words threshold. Okay. I know from all that authoring time that just one frame at 24 frames per second is good. So let's just add that as a constant up top. Equals, do I have some other consonants that I should pull up to the top? Yeah, this stuff here. Let's do that. Let's put it all in one place. Right before all this. And I don't really feel that it's coupled to the frames. It just happens that one frame happens to be that. That's a stupid way of talking. It happens that the time for one frame is about right for where you want to consider consonants is just group them together and make them be one thing. Okay. So if that's true, then we'll say what was 1000 by 24? 43 seconds or something like that. Let's say 45 milliseconds. Or not be so precise, 50 milliseconds. Okay. Okay, so if all that's true, then I need something like a last phoneme. It's more than that. It's more than that, isn't it? It's the last consonant, so let's do it this way. Let's see. More specifically, this is a phoneme timing. So I need to say this is going to be a phoneme timing, and it's going to be this. Okay, then this will be phoneme timing. Let's invert this, because I already set the spanning thing here. This will end up being the last consonant found in the word. I feel like I can always reset this up at the top to null. This I can invert. So we say if it's equal to 0 or the gap between the words, this and the previous, is greater than equal to the threshold. Greater, that's fine. Then let's clear out the spanning constant. Equals null. Okay, so that should correctly set the spanning consonant between words. then it's just doing this consolidate consonants thing. Oh, I gotta write this. Boolean. Boolean would be a good name for a child. If you name your kid Julian, why not just name him Boolean instead? Seems like a good name to me. It would help the kid be more decisive, maybe. You're either for or against something. You're very Boolean. Okay. So I can do this by getting the viseme and seeing if it's one of the consonants. Phoneme to viseme, and then we go phoneme. Let me say return viseme equals viseme consonant, or viseme equals viseme WQ. Any other ones? Yeah, well, of course there are. There's viseme MVP or viseme L. Any more? I got FV? Nope, not yet. Okay, I think that's it. Let me double check. Consonant MVP FV WQL. Did I get L? Yep. Yeah, that's it. Okay. Vaguely aware this is not the most performant way to check this, but don't prematurely optimize, I think. A better way to do it, if I really need to optimize it, would be just have a array of booleans, one for each phoneme. No, it has to be a map. It would have to be a map, which is what phoneme to viseme is doing. What it's calling an associative array. But that associative array could, instead of returning a viseme, could return a boolean, are we a consonant or not. Another way to do it is I could add properties of each viseme. I could say like viseme cons dot is consonant equals true. It's kind of interesting. Let me just play with that for a moment. Probably doesn't work that well with TypeScript. Is consonant equals true. And you'll say it's a, yeah. Viseme cons has any is, yeah, you can do that. That's not bad either, but again, that's like premature optimization. Okay. Okay, consolidate. So we break out the consonants. Const phonemes array equals this here. Well, since I'm already doing this work here to split it up, let's pass an array. Phonemes array. Although I'm going to have to get a fresh phonemes array after that comes back. So I really am splitting twice. think it's like const phonemes array equals this guy. Phonemes split, and then we'll do spanning constant. Yeah, that one. Okay. And then this can go back to being a const. And I need to see where else it might reference that. Okay, what? Okay, that's fine. I can fix that. I don't know why this is messing up. I'll fix that in a moment. Let's yank that back out. This is phonemes array. And this will be another array. Return phonemes array. Okay. Come back down here. We're good again. Okay. Phew. Okay. Phonemes array for each. And we will do phoneme. No. Okay. So I need something like best phoneme or something like that. Okay, I'm also returning this array of phonemes. So let's see, const consolidated phonemes. Okay. Let best phoneme in group equals what I can do, bam, like that. Well, it's more like best viseme in group. Okay, then there's like, are we in a consonant group or not? What is in consonant group? Boolean equals false. Okay. Put this above so it's easier to find it later. I like things in calling order. This would be a viseme. And let's be better than best. Let's say most expressive viseme group. Okay. Let first consonant phoneme. First group I number equals I don't know, 0 for now. Okay. All right, so then we want the viseme for the current phoneme. Phoneme to viseme, and then phoneme. Or there. Let's see. Function is consonant viseme. So we say if is consonant viseme. If we're already in a group, let me say if is viseme more expressive, this current one, than the most expressive viseme in the group, then there will be a replacement. And I think I can set this. I'll figure out the spanning logic a little bit later. Okay, let's first get this part working right. Okay, so in this case we say we're going to replace in the consolidated phonemes first consonant group I equals the viseme, and then we'll say the most expressive is going to be changed to this one. That'll be the one to beat next. Okay, now you're complaining about something. Oh, yeah, this is not going to be the viseme like it said, it's going to be the phoneme. Okay, cool. Okay, that makes sense. Otherwise, nothing to do. True. Am I winning? Nick Blue? Say something that makes me think you're not a bot. Just say one thing that makes me think you're not a bot. All right, you passed my Turing test. I am winning. I am winning every day. That was a good statement. I like the taste of hot dog water. Yeah, who doesn't? Who doesn't? Just fill up a whole stein of hot dog water and just suck it down. It's good stuff. Throw out the hot dogs. Just drink the hot dog water. Oh, yeah. I wonder if vegans would drink hot dog water. No, they wouldn't. They wouldn't, because you had to kill some animal to produce the hot dogs, which meant that the water is based on animal suffering. Okay, so let me say it's in the consonant group. Okay, if it's not in the consonant group, then we have to initialize these variables for entering into the consonant group. So we'll say Pam true, and the most expressive value in the group will be the current one equals visine. Okay, and then I gotta push the consonant to the consolidated phonemes. Consolidated phonemes, push current phoneme, and first consonant in group I is going to be equal to the length of consolidated phonemes. Yeah, I agree with your analysis concerning the behaviors of vegans and vegetarians when confronted with a choice regarding hot dog water. Totally agree with your analysis, sir. You're making me hungry for hot dog water, or thirsty for it. I guess both. I mean, I might have to take a break pretty soon just to see if I can locate some hot dog water for myself. I think like just had 2 liters full of hot dog water, like right next to the Pepsi and Coke. Now that would be ideal. Just grab yourself some cold, pink, carbonated hot dog water. It's not been done before, I would wager, but it could be. It could be. There's a whole new frontier of tasty beverages. Yes. Okay, so push that. Yeah, I don't want to move into the next part because I gotta go get lunch or brunch. So I gotta leave some notes here, and then what I'm coding is an automatic detection of lip animation given an audio file as a starting point. So we take an audio file of someone talking and we say, here's all the words inside of it. And then, yeah. So anyways, that's what I'm working on. Then you asked another question, and seems like an interactive storytelling framework would just require prompt. What would you do? Yeah, there's different ways to skin that cat, though. So what you've said is in a kind of a simple way. That is what my framework intends to do. There are prompts, but it's also based on some other sensibilities that I found have worked well in past projects of mine. One is the idea of a spiel. A spiel is like a thing that a character wants to say and talk through in a somewhat linear fashion, but I'm allowing for interruptions to that spiel. If the player wants to say something and interject, ask questions while the other character is talking, or like when the character pauses for a moment, you, the player, could say something. I mean, like say something out loud, and the speak recognition would match it, and take you to different points of conversation based upon that. So that's the gist of this framework. That's kind of the new thing. It's like you will be able to use this to talk to characters, and they won't be so smart. You mentioned chatbots. They won't be so smart as like to have AI that comes up with something for everything a person might ask about. Instead, we'll say, here's kind of the spiel that we're going to get through for the character, and there might be some things that are likely to come up and we'll match specifically against those. So almost like a very simple stimulus response behavior. And all of the scrape for terms, but all of the audio, it won't be like generated like speech synthesis. It'll come from voice actors. That's another thing that I've worked a lot with. So you'll have like properly acted speech coming from the characters and animated faces showing that speech. And yes, we'll be scraping for certain expected player terms, keywords and such, to branch off in different directions. So it's not like a complete illusion of realistic conversation, not at all. It's just like you can feel like it though, because you'll see a face in front of you talking and it will react in a lot of the same ways a normal face would when you're talking to it. And you'll kind of get to know, like, okay, if I hit certain keywords in the conversation, it's going to move me in different directions and stuff like that. So that's the gist of it. But I'm going to set a stopping point here because I got to go eat some brunch. Cool talking to you, Nick, but I'm going to stop the stream for now. I may come back later. So I will say goodbye, sir. Thanks for the tip about hot dog water. All right. Stopping the stream. Stopping the stream. I am stopping the stream for carbonated hot dog water.